Hello, Core Buddies. A lot of people had requested us to create a basic introduction to the system design process. And we at CoreBuddy do understand that system design can be daunting. There are a lot of keywords flying around HLD, LLD, FRs, NFRs, and they can be scary for anyone. So, today, what we're going to do is break down the system design into various stages. In each of the stage, I'll give you a brief introduction and also tell you the essential reading material, which will help in kickstarting your system design. So what are we waiting for? Let's get started. So guys, now let's see the stages of system design. The first stage is the API design. In this stage, we will take in a vague problem statement and come up with the API design of the system. Now, once we have the API design, next step is to come up with the low-level design, which is also known as the LLD. The next step is to come up with the high-level design, which will basically give us a high-level overview of how the system would look like and its various components. Now, once we have come up with a high-level design, the next part is to scale it up based on the constraints of the system. We'll talk about it. And the final part is the caching layer. Why is caching important? Where is it used? And what is the purpose of it? And why I am even covering it as a separate topic. We'll talk about all of this. So now let's first talk about the API design. So in API design, basic idea is to understand what the system does, or what are the ways of interaction with the system, or what are the functional requirements. So let's take an example. Whenever you're presented with a system or a machine, the first question which is asked is, what does it really do? So this question is basically aimed at gathering the functional requirements. So what you're trying to understand here is, what can I do with the system, or what can user do with the system? Or in other words, what actions does it perform? So let's take an example, a concrete one. Suppose you're given a problem, design a social media platform where users can register themselves, view timelines. So what are the functional requirements of the system? Users can register themselves. That is, people using the system can register themselves in the system or create profiles. Users can also view their timelines. So now, once we have the functional requirements, that is what the system can do, let's try and convert it into APIs. Let's take the first example. Users can register themselves. So what is the noun here? The noun here is the user. What is the verb here? Verb here is the register, which is the action. So what is the API for the system? The API for the system is post/user. But the important point here is that from the functional requirement, we need to first identify what is the noun in that functional requirement, and what is that verb, meaning what is the action being done. So if you see, the post defines the action. The post method defines the action. And what is the noun, or what is the entity being acted upon? It is the users, since the users can register themselves. So hence our first API becomes post/user. It is as simple as that. So let me point you to some essential reading material. If you want to read through HTTP methods and status codes, this is the resource that you can access. The other thing that I would recommend is REST API architecture. There are a number of API architectures, but REST is quite prevalent, and it's still in use. However, it's facing a lot of competition with gRPC and other architectural styles, but REST is still a standardized one. Moving on to the next step. Once we have our APIs, that is the post/users, we can move towards the low-level design. So what do we mean by when we speak of the low-level design? So the basic idea here is to create entities of the system and draw relationships between them. How? So let's say we have our previous API, that is the post/user. So entities are typically the nouns of the system again. So what is the noun in the post/user? What is the object being acted upon? It is the user object. That is the noun. And what is the action? The action is the post. That is the register, if you remember. So the first entity automatically becomes the user entity. Now we will be adding attributes. So obviously the user, when they will register themselves, they will add more information. Like let's say you go and register to a platform like Facebook, Twitter, or Instagram. What you do is, while registering yourself, you add your attributes, and these attributes can be your email, can be your name, and can be your phone number, right? But the important part here is that what is the parent entity of all these attributes, and that is the user entity. So now let's extend it a bit and make it a little more complicated. Let's take the next API, the post/post. So in this, what is the action? The action is post. And what is the object being acted upon? That is the slash post. That is the post. So the entity becomes the post. Let's add some attribute to the post entity. The attribute can be the user, basically who has created the post, the image link of the post, and then the description of the post. Now it's time to draw relations. So as you can see in this diagram, there are two entities. One is the user entity and the other is the post entity. The user entity has its own attributes, and there can be many more. Similarly, the post entity has its own attributes. However, we do understand from the requirements that a user can create posts. So there should be a link between the user entity and the post entity, and that is the relation that you're talking about. So when the user creates a post, obviously we need to understand that we also want to capture the information of the user. And that is why we store the user ID and we link it to the user entity. Now, what are the essentials of this stage? First, we should understand what are entity relationship diagrams. So what I showed you previously was one example of it, a simplistic one, but you can go on and read further from this link. Also practice some entity relationship diagrams, which you can do from this link for hospital management. And then there's also an advanced example that I've picked, and you can go through this. This is drawing an ERD, which is the entity relationship diagram for simple board games. So now let's move on to the HLD. So in HLD, it's important to understand the constraints of the system. So what are the constraints of the system or the non-functional requirements? Why are they important? Based on these constraints, you will be actually defining your components of the system and your system's design, the high-level design. Questions like how many requests will the system get per unit of time? What will be the ratio of reads versus writes? Is some of the examples of the constraints of the system. Since this is a broad topic, let's split it again. So the first layer in a high-level overview or a high-level design of the system is the load balancing layer. Then comes the stateless services, which is the brain of your system, the logical part of the brain of your system. Then is the stateful services or the databases. That is, again, the brain of your system, but it is the storage part. We'll talk about each of these in the following slides. Let's talk about the load balancing layer first. So this layer, as the name suggests, has the responsibility of dividing the network load amongst the instances that it covers. That let's say you have 5 workers, or I'm talking about physical workers who have to do who have to perform, let's say, 100 jobs. Some of the workers are weak, some of them are strong, and some of the jobs are shorter, some of the jobs are longer. And you are the one who is assigning jobs to them. So then you act as the load balancer based on the size of the job and the health of the workers. So one of the strategies can be that you will assign heavier jobs to the most powerful worker and smaller jobs to the weaker workers. Other strategy can be that you will assign the jobs in a round robin fashion. That is, assign the job in a circular fashion. First, you will start from worker number 1, 2, 3, 4, 5, and then come back to 1 again. Basically, the idea here is to balance the load, which is the network external load, that is the requests that are coming from the users, to the workers or the layer below the load balancing layer. Various strategies, like I discussed, are used. First is the round robin strategy. Then we have a resource based strategy, and there are other strategies as well. The next layer is the layer of the stateless services. This layer lies just beneath the load balancing layer. The responsibility of this layer is to
consume user requests, and transform them as per the business logic. The logic in the system will reside in this layer. And it also has the responsibility of not storing any results. The results will be the results will be computed by this layer and then transferred to the next layer. As a rule of thumb, if we have to define our services, what we can do is take one entity that we have defined in the previous level and translate one to one it into a service. So in our case, the first service becomes user service because our first entity was user. Moving on, then we have the stateful services. So until now, we have covered two layers. That is the load balancing layer, and then there is the stateless services. Now we are coming to the stateful services. The responsibility of this service, the stateful services or the databases, is to store the results and don't lose it. Typically, this layer is supposed to be the persistent layer. You have to store the data that you have computed. Let's say a user comes and registers themselves. You don't want the user to register themselves again and again. So what you'll do is you will store the results, and this is the layer where you will store it. So what does this layer contain? Tables. So how do we come up? So how do we come up with a data model? I'll tell you a simple trick to convert a basic entity set into tables. It's very, very simple. It's basically one-to-one. It's one-to-one translation. What you can do is we have already listed down our entities. That is the user entity. The corresponding table to the user entity can be the user table. However, this is very much subjective and it depends on the problem statement and the system that you are designing, but this can be a good start. Similarly, a post entity will become a post table. So entities are tables. Not always, but a lot of times. So what are the essentials of this section, that is the HLD? First, I want you guys to practice ERD to service translation logic, basically coming up with the entity relationship diagram as in the second part, the second stage, which is the LLD stage, and then translating it to services. Like we saw for the user entity, we created the user service. Typical examples that you can practice is the hotel management software, hospital management, flight management, and you can find a number of examples on the internet. Understand the concepts of relational databases. Now, a lot of these concepts overlap with the concepts of entity relationship design or diagrams, which we have covered in the second section, but you should go and read through the concepts of relational databases. These not only form the foundation of your high level design or the database layer, this also helps your transition from the MySQL world, which is the relational databases, to non-relational databases or NoSQL. So I would want you guys to cover the following points in the relational database section. One is the asset properties. Second is the keys, the primary and the foreign keys, candidate keys, joins, and indexes. I have given the useful links which you can follow and read about them. So this is what the final picture looks like until now. So the first box contains the user, client, app, world, basically anything outside the system, right? The first layer in our system is the load balancer, like we discussed. The second layer is the stateless services, which is our services. And the third layer is the databases, our stateful services. In our example, the app, client, user, world is everything outside the system. Like I mentioned, the first layer is the load balancer. Second layer, for our example, becomes the user service, post service. And the last layer is the database, which can have the user table, post table, and the relationship between them. So what next? We have already come up with our component design. We know that this is how the system would look like. But what is next? Now the entire story revolves around managing the non-functional requirements. So what do I mean by that? So non-functional requirements, like I discussed, are the constraints of the system. So for example, load increases and hence the system becomes slow or unresponsive. So imagine that your social media platform that you built is becoming very popular and suddenly a lot of people started using it. Now, what you had imagined that you had just made a system for your friends, and you had imagined that me and my friends would use it, and I think it would work with a one MySQL instance and two service instances. However, suddenly your website blew up, and there are a lot of people coming to use it. Imagine all the load from Facebook translated into yours. I have a typical situation, but let's imagine that. What will happen? Your each of your layers will get choked and will get slow or unresponsive. So what should we do? Scale. Yes, that is what we will do. Addressing scale. In this section, the game is really about devising strategies to manage the scale or the pressure on the system. Scenarios like your simple social media website has suddenly blown up and everyone started calling your API post/user. Now your machines have limited resources and they become unresponsive. So what will you do? Scale. Scale, but how? Are there any principles or at least some advice? How should I scale? I have come up with a simple design until now, but how should I expand it? So now what I'm going to do is in this section, I'll tell you some of the basic theories that you can read and understand, which will help you as guiding principles to expand your basic system design. The first and the foremost is the CAP theorem. So the link that I've attached here is probably one of the best illustrations of the CAP theorem that I've ever read. It's in simple English and will definitely clear your doubts around the CAP theorem. The CAP stands for consistency, availability, and partition tolerance. Then comes the master slave architecture. In this link, you can read up to the create environments section. The illustration is pretty simple here. Then you should also read about database replications. Next is sharding. So the link that I've attached here will give you deep information about sharding and all you would need to know to kickstart your scaling up process. Moving on, we would also recommend that you read about at least one blob storage, that is the Amazon S3. Don't worry about it if you haven't heard this word or if you're not confident about what a blob is. The links that I've attached are pretty simple to read and understand. Also, read about message queues. This link contains its use cases and when it should be used. Understand one queuing system, and that is Kafka. Now, why I emphasize over Kafka is because Kafka is being widely used both as a message queue and in a publish subscribe model. It's important to understand it because it's heavily used and you don't want to miss out. Lastly, I also recommend that you should understand the access times of various hard disk drives, SSDs, RAMs, and all the memory or the stateful services. The link that I've attached here actually gives us a chronological order of latency improvements in the access times of the stateful services. Okay, this is the final part in the system. In this section, I'll be talking about a very special technique of improving the response time of the system. So what is caching? Caching is basically storing the information which is already computed for faster access. Let me ask you a question. What is 1232 multiplied by 67? Take your time. It's 82544. Okay, let me ask you a question again. What is 1232 multiplied by 67? Yes, you know the answer. It's 82544. And why do you know the answer? Is because you have stored it in your brain and it is something that you have already pre-computed. So caching is the art or the strategy of storing pre-computed information and accessing it before going to the actual data. An interesting and similar explanation can be found in this link, and I highly recommend that you guys go through it. Yes, but where should I cache? Where should I put my cache and where should this layer exist? Where does this layer sit exactly? To be honest, it can really sit anywhere. In fact, you just used it right now in the example that I showed you before. Wherever you want faster access to improve latency, you can put this layer in between. So this is like that magical layer which will improve your latency times, which will help you to store information. But typically it sits before the database layer so as to improve the database access times. So this is how our final system looks like. This is the user, client, app, world, basically everything outside our system. And below the dotted line is actually our system. The first layer is the load balancer layer. which is followed by the user service, the post service, which calls the caching layer. There are various strategies of caching, and we'll surely cover them in further lectures. But this is how our system looks like right now. As you can see, this is basic component design. We have the APIs, we have the entity relationship diagram for our system, and we also have a basic component diagram for our system. Now you can use the references and the reading material given in each of the stages to expand the scope of your system based on introducing new constraints. But this should work as a good starting point. So that was all from my side today. I hope with this video you can at least kickstart your system design process and not get afraid of how should I approach a problem. Now you know that you can break down a problem into various stages and how should you move from one stage to the another. Please leave your observations, comments, suggestions in the comment section below. Thanks a lot. See ya. Bye-bye.